Good after morning. We're going to go ahead and start talking about making our first file. I'm going to move this over here. Let's make our first file today. We're going to be working in Inkscape. Now on the customer portal there's a lot of videos to show you how to use Inkscape, more of everything that you want to do with Inkscape. So please feel free to watch those. However, I am going to go ahead and start off with just a very basic file here. I love making it. We're going to go and click on our Create Rectangles and Squares file. Tool there. We're going to create a square. Like the look of that square. Okay. And let's go ahead and add a name. Now, we're just going to start off with, we're going to put Bob. The reason I'm putting Bob is, as a name, it has a lot of unique things that for plasma cutting can get interesting, and we want to be able to address that and fix that when we're cutting it, and when we're designing it as well. I'm going to go and set that there. Looks good to me. And I was using that text tool there. Next tool we're going to use is our Draw Bezier Curves. Let's go ahead and do that. We're just going to make a line. I click once, and look at that tail. Hold Control, and boom. Cool. And I right-clicked to remove that little tail, or essentially say, I'm done with this tool, I don't need to make any more lines. Right-click, and it's done. Let's go to our pointer tool and see what's going on. We're going to get close. Alright. Moving on here, we have this thing called a vector editing tool. It's a tool that helps us edit vectors, strangely enough, as it's called. And you'll notice that if it's a vector, it's going to start to light up in red first, and when you click it, it has nodes placed on it. However, if I do that with the text, there are no nodes. And what you need to understand going into this is that for the plasma cutter, or for our table to cut any design, it needs to be a vector, whether it's a CAD or DXF based vector, or if it's an SVG vector. We need vectors. Vectors give dimension. They give starting and end points, so that the computer knows, hey, I'm going to make a line that's 4 inches from point A to point B, and point A has this coordinate over here at 0, 0, and point B over here has a different coordinate at 2, 2, so it's going to travel in a diagonal line 2 inches up and 2 inches over to my other point. All of that information is locked into those vectors. We have very specific distances and relationships between every line and character in this vector setup. And we need things to be vectors to cut it. So Bob isn't a vector. Let's go and make him a vector. Inkscape has a really cool tool to take any text that we want. I'm going to go ahead and click on the pointer tool there, click on Bob, go Path, Object Path, and now if I go to Edit Paths, my node, looks like we have some vectors. Now, there is something about Plasma where we notice, okay, there's a lot of nodes in here, and we don't want that to be the case, because the more nodes there, the dirtier that cut will come out to be. So I just go Path, Simplify, or there's a keyboard shortcut. I go Control L, and it will remove vectors for me. Control L, cool, simplified that down a bit. It's not the best condition. What ideally we would do is we'd remove a couple of these little points here that seem unnecessary. That one seems a little unnecessary. That one seems redundant. And we can go through and click and delete. And I have another video that goes through that. We're not going to go through that now. I'm also going to click on my name here, the Bob name, and I'm going to remove our stroke and fill. So I'm going to remove our fill and add stroke. So over here, fill, clicked here, stroke paint, clicked here. And if you hover over it, just says flat color. You could go real fancy and have this gradient that appears over the image. Cool. It just makes it really difficult to work with on a vector platform, especially on what we're trying to do. Alright. Now, if we were to just cut this square out of aluminum, let's say, we'd run into this issue where that B, the center of the B's, will drop out of the material. All you'll have are these weird B-shaped holes without actual insides of the B's. No one wants that. So I'm going to go over here and create a rectangle right here. I'm going to click on it once and turn it because I want it to sort of follow the shape. Cool. Now I want to copy this. Paste it and paste it because I want to do this 3 different times and I want them to sort of be the same. We're going to click on our vector editing tool. I'm going to click on the square, hold shift, keep holding shift, and click on the B. Path difference. Same thing. Click on the square, click on your letter, hit path difference. Click on the square, click on the B while holding shift, and then hit difference, and we've now slotted our letters. It's a really simple and effective way to slot our letters. The last thing I like to do at the end of a design is I select everything and then I go path combine, and all it does, it just makes sure that everything is A, on the same layer, and B, grouped together. So if I were to try to mess with this, I can't just grab the letters anymore. I have everything where I want it to be, and I'm not going to mess it up because it's so easy to go back and accidentally hit something, go to cut it, and realize, oh shoot, I made this wrong. So let's go let's go desktop. We're going to go save this. I'm going to save this as bobname.svg. Okay. We're going to hit X. Alright, and let's go ahead and open up SheetCam TNG. Good old SheetCam. So once we've designed a file, we need to open it up in SheetCam. While in SheetCam, we're going to open up a new part. So File, New Part. I'm going to click on that. Do I want to import a part into this drawing? Absolutely. Okay, and let's go to our desktop here, and we have Bob name. Awesome. We're going to hit open. Now we get this screen. Now, in a previous video with Inkscape, we made sure that our Inkscape was in inches. So my Inkscape files are all going to be in inches, and SheetCam, by default, is in inches. So my scaling should be 1:1. If I was using millimeters and I was going to inches, my scaling factor would be completely different. So recognizing that, it's a 1:1 scaling. I'm going to hit open. And our shape shows up. Now in SheetCam, the red area represents the space that you, on the material that you have. Now this is I believe, let's go ahead and pull this up. Options, job options. Let's take a look. So I'm working in a 2-foot by 2-foot area. I like it. It's 24 inch by 24 inch there. Okay. So this is a little larger than a foot coming into this because it's 2 and 2. 2 feet, 2 feet. Or 4 square feet. Now, when you're looking at this particular piece of art, we'll call it art, we notice that there's 3 different colors here. We have the white, yellow, and red. Red stands for an outside shape, and yellow stands for a shape inside of another shape. So if this outside line wasn't here, the BOB would be red, and there would be no yellow because there's no shape inside of these vectors here, these vectors down here. Now, white line represents any line that isn't a shape. And when something is a shape, it has no end points. It's just one continuous line. That's what defines a shape in this. There's no specific end points. And because a line here has endpoints, it's going to show up in white. Now this is going to be an important thing to notice because you may design something and you're wondering why is it not cutting out correctly. Well, it may be that your shape, or what you thought was a shape, is a line, and SheetCam tries to cut lines differently than shapes because shapes have an inside and an outside. And like many of you who have potentially cut wood or 2x4s, we know that we can cut on the outside of this, and it will be preserving the integrity and the scaling of this shape, as opposed to cutting on the inside of this, if I could draw, and it preserves the integrity of the outside shape. So whichever side of the wood, or in this case the metal that you're saving, you always want to make sure that the blade width is put on the outside of it. And we're going to address that when we go into operations here and start adjusting some things. So let's go to operations, and we're going to see this little create a new jet cutting operation. Alright. I have a 16 gauge simulator here. On our customer portal we have a lot of tools for particularly the Hypertherm machines that'll get you started. Let's see here. Outside offset. So as I was saying, our blade is going to be on the outside as opposed to the inside. And then layer, color 0. We always want to select a layer. If you don't have a layer selected, if this is blank and you don't have a layer selected, your machine isn't going to attempt to cut this at all, because it doesn't know what layer it's trying to cut on, even if there's only one layer. Let's go ahead and hit OK. Perfect. So you're going to see that the blue lines are the travel line, or where the plasma is off and traveling between things. And the green line represents actual plasma cutting time. One of the important things to note is you see this little tail here. This is all part of something called the lead in and the lead out. And we have two arc lead in and lead outs. That is to say that when the plasma cutter comes in, it's actually going to start on the outside, and you're going to inevitably get a deeper and wider pierce hole when your plasma initially fires. So you want to move the outside of your piece so as not to give it a weird dimple. Come into it and cut around your piece. It's going to cut, come back, and then it's going to arc out. Now similarly, you could say it would do the same thing here, arc in and then arc out, and you'd get some shape that sort of resembles that. So make sure that when you're setting your piece on your table, that your lead in and lead out is set correctly, that you're not having to deal with the insanity of accidentally cutting outside of your workable cutting area. It's a bit of an issue. Alright. And one way to adjust that, we're going to go ahead and touch on that right now, is we can actually take this lead in and lead out, and using the edit start points function, click here, and it'll change where it's leading in and leading out. And you notice it's been moved to here, or it could be moved to any of these points. By using the S+ tool, we can adjust those start points. Yay, go us. But with this, looking at everything here, looks like my lead in and my lead outs aren't doing anything funky here or here. I'm going to go ahead and save this file as a G-code file, or processing it. So what we're doing here is nesting. Technically, we could go in with our nesting tool and nest multiples of a specific file onto a sheet. However, with the size of the piece that I'm working with, I can really only fit one in here logically. Unless, of course, I had a bigger working area. We don't. So, we're going to go File and Run Post Processor. The shortcut for that is also here. That green P is also Run Post Processor. And we're just going to call this the Bob Name G-code. Cool. We hit OK. And if we want to, we can save this file. I'm just going to go ahead and minimize this. Let's go into Mach 3. And as we go into Mach 3, it's going to say R&R Motion Controller. I'm actually, when you're working with your 2x2 table, you're going to need to click this. For the sake of this video, I'm actually going to click on here because this computer runs on a slightly different operation. We're going to hit OK. We're going to hit Reset. Perfect. Let's load a G-code. So here we are in Mach 3. We have a lot of different tools, most of which we actually don't use in this particular setting because, again, Mach 3 covers a lot of different types of tooling, a lot of different types of table functions. So you have routers, and you just have a lot of options there, and we're not doing that here. We're just doing Plasma, and Plasma is relatively simple in comparison to the other processes out there. Let's load our G-code, and let's go to desktop, and we have Bob name, and then we need to make sure that it's a .tap file. If you don't see your .tap file when you open it up, when you you're in the place where you saved it, oh my goodness, where is it? You can always select all files, and you'll be able to see, okay, cool, there is my .tap file. We're going to go ahead and hit open, and this is what it should look like. You should see post processor type and date and a lot of this information available all up here. If you're not seeing this, it may mean that you've loaded the wrong file type, which is and can be a little bit of an issue. Make sure you're loading that .tap file. And over here on this side of the screen, we do see sort of a preview of that shape, a preview of what this actually looks like here. That's not where we want it. It looks like the 0 that we have right now is -14 down and 1 over, and that's nowhere near where I want to put it. So using our up, down, and there we go. Clicking off of that. If you have this clicked and you try to hit your mouse, it's just, hit your up and down buttons, it's just going to move this. Not okay. Cool. You can hit your up, down, your left, and your right buttons. And you can see that the values here are changing. Same thing with my 0Z. My Z is my page up and page down. Now, with your particular setup on the 2x2, you may not have a Z-axis motion up and down because you don't have a THC. So THC comes with that Z-axis. But let's go ahead and hit my 0Z, 0X, 0Y, and when I click Regen Toolpath, I want you to notice something here. The reason we zero this out, so we move our head of our table to the bottom left-hand corner of the material that we're trying to cut. We 0X, 0Y, 0Z, hit Regen Toolpath, and you'll notice the screen fills up with the actual CAD that we drew out. Reason we do that Regen Toolpath is whatever file was loaded into here is based off of whatever previous 0 was already loaded into the program. By regenning the toolpath after zeroing, we're saying this is the new 0. This is where we want this file to start cutting. And it'll start cutting from there. And it'll make your B, your O, your B, and then make the rest of the shape and cut it out in that bottom left-hand corner. So you always need to zero it out, always need to regen toolpath. After that point, we hit cycle start once, and it's going to stop right here at your tool, and you're going to need to hit cycle start one more time, and it'll actually run down to wherever it needs to go to start making all of those cuts. In any case, that should get you going on your first cut. You're going to notice here you have your yellow light flashing, meaning that the torch is actually on and firing, which is a good thing. And it's going to be off every time that the code requires it to be. So here we go. It's on. It's back on. It's cutting. And if we follow the screen closely, it's going to finish off the B. M05 means it's off. It's going to go up 0.75, move to a new position, go down, and then turn on, and then start moving again. And that's how it goes. In any case, we're going to go ahead and hit stop here. And there are a lot of other support videos that show you how to do so much more from here, but I just wanted to get you going. Feel free to take a look and get running as soon as possible. Thank you.